Hello everyone. Today we'll be learning how to graph polynomial functions. Let's begin. In order to be able to fill out this table below, we must first graph the function. So, as you can see, our function is f of x equals x parentheses x minus 2 parentheses x plus 3 parentheses with the exponent of 3. Okay, so first we are going to place our points. So we have x 0, 0, x minus 2, but since we're switching the signs, it's going to be x plus 2 and negative 3. Okay, so since we have an exponent of 3, the line is going to go up. Gonna go up and it's gonna curve a bit on negative 3. Gonna go straight across 0 and it's gonna go straight up on 2. Okay, and this is your graph right here. Now we can go to function degree. Our function degree is 5, and as you can see, we only have 3 exponents here, but there's an invisible 1 in front of every x, so that gives us a total of 5. So since we have a function degree of 5, it's an odd function because 5 is an odd number. Okay, and because the graph is pointing up, we can tell that is going to be a positive function. And in order to find the end behavior, we have to look at the points of the graph, the arrows of the graph, wherever the arrows are pointing. Okay, so as x approaches negative infinity, f of x is also going to be negative infinity because the arrow is pointing down. Okay, and as x approaches positive infinity, f of x approaches positive infinity as well because the arrow is pointing up. Okay, and our x-intercepts would be negative 3 and 0, 0, 0, 2 and 0. And our y-intercept would be just 0, 0. Okay, now moving on to multiplicity. In order to find the multiplicity, we not only have to look at the graph, but at the exponents. Okay, so we can see that there's a linear root on the 0 right here. So you can put, there is a x equals 0, and there's a linear root. And then we can see that there is also another linear root on positive 2. So we put x equals positive 2, and there is a linear root. And then we look at negative 3, and it's a cubic root because the exponent is 3. And let's keep in mind that an exponent of 1 is a linear root. An exponent of 2 is a quadratic root. And an exponent of 3 is a cubic root. This is how we can tell whether it's a linear, cubic, or quadratic root. If it has an exponent of 1, it's a linear root. If it has an exponent of 3, it's a cubic root. And if it has an exponent of 2, it would be a quadratic root. Okay, so since it's a negative 3 and the exponent is 3, it's going to be a cubic root. In order to find the increasing intervals, we have to look at the graph and see where it's increasing. So it would be all of this that's going up, as well as this. and this, and then it decreases all right here as it goes down across 0 in order to go up to positive 2. Okay, and this is how you find a linear and cubic polynomial function.